device that has been designed for fractional skin resurfacing and dermatology surgery, and has very specific and very new technologies on board. The way that this device is treating the skin is absolutely unique, and I would like to try to explain to you as better as possible. As of this stage, I prefer to show you a video of the product, because maybe it can be a little bit more friendly, the understanding with this as a first approach. Here. So, we can start from this, trying to stop sometimes and just explain, and then going deeper a little bit through the presentation. So, YouLaser MT. MT means mixing technology. YouLaser MT has two different lasers inside, 1540 nanometers and 10,600 nanometers, so CO2. And what was the erbium glass, now gallium arsenide, is another kind of source that is emitting the same wavelength, 1540. Both the wavelengths are well recognized because 1540 is the gold standard of the non-ablative lasers for fractional resurfacing, and the CO2 is the gold standard of the ablative lasers. So this device has on board both the laser sources, and they can work alone. So we can decide to switch on just one, it's a bit noisy, to switch on just one device, or to have both active and working with them in sequential or simultaneous, with sequential or simultaneous emissions. Like that, this is the technology that is explained. The video is explaining how it's working, this technology. So just the CO2, just the 1540, or sequences in the same dot, sequences of both the wavelengths, or mixing really simultaneously both the wavelengths. This was done like that because one of the first choice that any operator has to take when they are selecting a fractional resurfacing device is, I want something that has very fast results but cannot be applied to everybody, because it's considered too aggressive sometimes, because it's dangerous for that skin, because my patient was no downtime, for different kind of reasons. So, or I want something that has absolutely no downtime, but I know that I need repeated treatments, a lot of sessions, and anyway, on some kind of problems that the results are minimal, like for example, wrinkles, deep wrinkles. With this device, first you have both the wavelengths on board. So the first approach is I can switch on one or the other one, and depending on the patient I have in front, I can select the right approach to this patient. But what is really new in this device is that using them together, we can take the advantages of both the wavelengths for each patient in a single session. We can do that reducing, anyway, the healing time, so reducing the downtime, and increasing really in some conditions visibly the outcomes of the results. All the devices has a scanner for the fractionated emission and surgical handpieces for dermatology surgery. The scanner is working like that, creating a spatial interlace pattern with two kinds of scanning mode, reticular for high density treatment and big treatments, and constant distance for high intensity treatments when we have to go really deep. This is the kind of interleaving. So we, like that, we manage the thermal diffusion to be present because the tightening need thermal diffusion, but well balanced without being too much aggressive. And because this is absolutely unique technology, now presented almost 2.5 years ago, so with hundreds of devices worldwide now, But because it's a unique technology, it was very important from the beginning to give to the operators information to understand what they are really doing. Because for each setting, we want to know exactly how deep we are going with two effects we have in the same treatments: coagulation made by the 1540 and ablation made with the CO2. And the third one, which is important as the previous two, the treatment density. Because changing the setting of a laser, we are changing also the effect on the other one, and you cannot obviously become crazy trying to understand what is happening. We introduce this function that is called OptiSym. Every time you are pressing ready, you have the estimated depth of both the effects and the treatment surface for each pass, dynamically calculated. So, modifying one value, all three values, sorry, would be adjusted dynamically. And you know exactly what you are doing. So, ablation depth, the coagulation depth, and also the surface treatment. All the three values are important for the outcomes and for the safety of the treatment. So, two lasers in one device with this revolutionary really approach for the rejuvenation, and not only, because it's really giving great satisfaction in treatment of scars and acne scars. So, post-surgical scars, acne scars, keloids, due to also the effect of these two wavelengths that are in the scalps, for example, managing the instability of a keloid through the vascularization of the 1540 made by the 1540 and the ablation at the same time. This is an example of a treatment of acne scars. This is an example of a keloid, where we are doing both things in the same moment. How is working really this device? So two shots, or a single shot, where the 1540 is creating coagulation. Coagulation means that the skin there is in necrosis, will go in necrosis. It's not immediately visible. The necrosis in this case is visible typically about an hour after the treatment. If we make an histology immediately after the laser shot, we cannot see anything. Because the temperature increase is not the temperature able to vaporize the skin or to melt really the skin, but is creating necrosis in typically 1 hour. And then the CO2 that is making the ablation at the depth we want. Both the effects can be from about 50 micron to about 1 millimeter, both. This is thanks to the different coefficient of absorption, the two effects. Because 1540 has a water absorption coefficient that is able to give an optical penetration to this wavelength of about 1 millimeter without vaporization. This is different. It's penetrating 1 millimeter, but with vaporization. So just creating a column of vaporized tissue is different. The optical penetration of the CO2 is minimal. It's a few microns. So it is vaporizing the tissue, creating really a hole. And just from this graphic, we can see the potentials of this product. Because what is really needed to create tightening in the skin? We need a strong hyperthermic effect. So we need to heat up the skin. And if we want to use the CO2 only, or an RBM, so an ablative laser, really we cannot create so much heat, but for sure if we want to stimulate the deep dermis, we have to ablate up to there. So we need 1 millimeter of ablation, for example. With the CO2 we can have fantastic tightening effects, but going deep and having very long down times and managing the patient for a long time. But if we just use the 1540 to create the tightening effect, going deep into the dermis, and then we add the CO2 that can be dim, but there's no sense in combination to be there. And keeping the CO2 much more superficial. We are, what is not doing the 1540, we are acting in the epidermis and in the papillary dermis to improve the texture, to remove the pigmentations, and to smooth the edges of the acne scarrings or of the deep wrinkles, for example. So in the same moment, we are working in two different layers, in completely different ways. The 1540, due to this coagulation effect, is also able to reduce the vascularities. And is really visible how, if a patient has some redness or some telangiectasia, just the 1540 is reducing. So 1540 reduce the vascularities, is also acting on the deep pigmentations. In the case of some melasma, for example, can improve it. And the CO2 is taking care of the texture and the pigmentations in a single session. For the scarring, if we have a white scar, hypertrophic, the 1540 is not really playing a big role. It's the CO2 that is ablating the scar. But if the scar is unstable or is red, must be stabilized before. And the 1540 is doing that. So in 90% of cases, they must be used together. In the acne scarring is the same. For acne scarring, for example, literature say that the 1540 is working well. And also the CO2 is working well. So now, why? We will see better the pictures after. Why we cannot combine these two effects that are working both very well for the acne scar. In this case, for example, is acne scarring after one session. The device, anyway, can be used as a standard single wavelength device, just non-ablative, in case of needs of really non-ablative treatment with zero downtime. Can be used as a normal 1540. In this case, we cannot apply it on superficial pigmentations or deep wrinkles because there's no results, minimal results. So we know the potentials of both the wavelengths. We are not, we can say, push for sure the same wavelength for everything. You have the possibility to choose the best choice for each patient. With the patient, we have to talk and to investigate what they can receive as a treatment and what they want to agree with you about the approach and about the downtime. And based on that, we can cure it. This is a 1540 only, where we can have some tightening. Also in this case, an improvement of the neck. But if we try on deep wrinkles alone, we will not have comparable results with the combination. Or we can use the device as CO2 alone. CO2 alone in fractional, in this case, as just sense when this was a CO2 alone and deep resurfacing, but there's no sense to do that. Just when there are some pigmentation, so some dyschromia, melanin dyschromia, and when we want to be very superficial, because this one can drill up to about 1 millimeter. But if we stay just in the epidermis, we can have a very homogeneous color with very short downtime also in this case, because we are superficial. High density, very superficial, the CO2 alone can be used, this sense to be used. In all the other cases, combination. Okay, here was a resurfacing around the eyes. As you see, all dyschromia.